Alright, so last thing to discuss will be relative motion and what that means. So it's how we look at how the motion of one object compares to the motion of another object. So for example, if you're standing here and you see this guy walking in the train's moving 15 meters per second that way. The guy's walking 1.2 meters per second in the same direction. When I'm watching that guy walk, he actually appears to be moving 16.2 meters per second, which is adding up the two vectors. If you're sitting on the train and watching it, you only see the guy moving this. But to somebody outside the train, he's definitely going faster. Now, let's say they're going in the other direction. Let's say I see this, and I see him walking opposite. Again, I just add the vectors, with this vector being the positive one, and this vector being the negative one, and I get 13.8 meters per second. Again, for the observer sitting there. So we can use vector addition to do this, and vector addition is a good way to do that, to find velocity, relative velocity. So let's say we look at this, okay, the two separate velocities, and then we see the total. We can see what's going on here, and using subscripts, we can clarify motion as to what the worker sees, what the train sees, the train to the ground, the train to the worker, and the worker to the train. So when you see these WGs and TGs, but these subscripts tell us what's going on in the situation. So, the train, right? So this is the worker to the train. This is the train to the ground. This is the worker to the ground. And that's how we can identify what's what. If they don't occur along a straight line, then we have to use other ways to solve these problems. So here's an example of that. A figure is climbing up the ladder while the train is moving in this direction. Probably not very safe, but we can look at it that way. So here's the guy watching the whole thing happen, okay? And we want to see how all these vectors relate. So I look at here, worker to the train is up, worker to the ground is this way. This resultant would be the worker to the ground. So train to the ground, worker to the train, worker to the ground. And that's what this guy's going to see. He's going to see a motion go in this direction of the worker while he's climbing up, instead of going straight up or straight over. And remember, when we add vectors, we can use tip to tail method if possible. So we're going to go back to this and we're going to put some math with it, okay? So he's climbing the ladder, okay, worker to train at 0.2 meters per second. The train is going forward at 0.70 meters per second. So this guy down here is watching this whole thing happen. We want to know what the resultant's going to be. And as you can see, we got ourselves a nice right triangle. We can instantly go to Pythagorean theorem to find this, right? So my resultant is going to be my vector of 0.7 squared plus 0.2 squared, and take the square root. So my resultant vector is going to be 0.73 meters per second. So that's how fast he's going to appear to be moving. Now let's find our angle. And we just go the inverse tangent of my y, right, 0.2 over my x, 0.7, and that angle's going to be 16 degrees. So we're going to see 16 degree angle from the horizontal, traveling with a speed of 0.73 meters per second. So we can relate the velocities of these two objects that way. Again, vector addition allows me to do that. So now we're riding on a boat, and this boat is traveling 25 degrees from the horizontal, and the river at a speed of 6.1 meters per second. The river's flowing upstream, so the river's flowing down at 1.4 meters per second. What is your speed relative to the ground? What is your direction of the travel relative to the ground? Okay, so we want to talk about terms of degrees upstream. So first thing I want to do is I want to look at right here the boat to the ground, the water to the ground, and then the boat to the water. The water to the ground's easy. The boat to the ground is going to be at an angle, which means I have to take the boat to the water and I have to break it up into x and y components. Okay, so if I want to find the x, I take my resultant, 6.1, and I multiply that by the cosine of my angle, which is 25. And when I do that math, and I find the cosine, I get 5.5 meters per second. So that's how far we're traveling horizontally. How fast we're going in the vertical is 6.1 times the sine of 25. And if 6.1 times the sine of 25 is 2.6 meters per second. So I have my x and I have my y. Okay. If I look at the right here, the water to the ground, the velocity there in the x is 0 because I'm going straight down, and in the y it's going to be negative 1.4 meters per second. So I add up all my x's. Okay, my velocity in the x is going to be 5.5 and 0, 5.5 meters per second, and in the y it's going to be 2.6 minus 1.4. So my velocity in the y is going to be 1.2 meters per second. So 5.5, and so then I use Pythagorean theorem to find my resultant. 5.5 squared plus 1.2 squared. And take the square root of that, and what I get is 5.6 meters per second. And then to find my angle, I just go back to theta is equal to the inverse tangent, right, of my y component, which is 1.2 over 5.5. And my theta turns out to be 12 degrees. And we're going upstream. So we're going 5.6 meters per second, 12 degrees upstream. And that will get us to where we want to be.